equal to the energy that you would lose in friction. So your frictional energy or your force energy is 1.75 joules. Determine the acceleration of the ball. Okay. Well, my frictional force has to be equal to my force of acceleration. So 0.225 has to go to m times a. There's your acceleration. How fast is the ball traveling immediately after being struck? Well, it stops with a 5 meter per second squared acceleration after 7.8 meters. How fast did it need to be going when I first hit it? 78 meters, or v squared is 78, v is 8.83 meters per second. And then what minimum force must be applied? Well, your minimum force is
I'm dumb.
F delta T is what m delta V is what caused the change in momentum.
I'm F delta T.
Okay? Again, this is the kind of problem that you're going to be facing in a couple of months' time. Your first part was force. Your next part was energy. Okay? Your next part was force again, then kinematics, then momentum. So the challenge is going to be changing gears. Okay? Going from one question to the next question and saying, oh, that's momentum. Oh, that is energy.
Oh gosh.
And the more we practice it, the easier that kind of thing gets.
Death.
Because,
the death problem.
Presently, when you take a test, you know that everything on that test, like yesterday, is going to be wave motion. But when you take the AP exam, question A might be wave motion, but question B might be, force. And question C might be something completely different again.
Alex, we're supposed to sign up for physics B, right?
Okay, what's the velocity of the tennis ball? Needed to be launched to hit the opposing ledge. Well, my opposing ledge, I'm only going to get there with a horizontal component. Okay, so that's VO cosine theta. Distance is 20. Solve for T. And then my vertical motion, which is down 5 meters, because that's my ledge, is 5 meters below my level. Okay, so this ledge down here is 5 meters below the top of the cliff. So I'm going down 5. My vertical motion is what's taking me there, so it's the sine function. There's the time. Okay? 1/2 a t squared, again, there's the time. Solve for your velocity, 12.5 meters per second.
I feel so dumb. Set T equal to each other.
Okay, so use your horizontal motion to find time, and then substitute that time into the vertical motion.
Substitute.
What I get? They tell you that the ledge is 5 meters below the, somewhere. This ball, both having a height of 10, are separated a total distance of 20. Launcher A, launcher B. There are small ledges halfway down each hill. So if each hill is 10, then the ledge is at 5. Halfway down. Okay, how long does it take the ball to hit the ledge? Just D is equal to VT. Okay? Once you know what V is, then you can actually solve for T. Up here, since you didn't know what V was, you didn't know what T was, you had to solve for T in terms of V. But then once you know what V is, you can go back and solve for time. What was the velocity with which the tennis ball must be launched? From B to hit the opposing velocity, the tennis ball must be launched, okay, then, oh, it's the same thing. Okay, different angles, but you end up with the same number answer. It's the same process. A, we had a cosine 30, B, we have a cosine 45, okay, and it works out that they both have the same velocity. Just because of the way the ledges work out with the distances and so on. Doesn't have to be that way. Okay, if the tennis balls are both lost simultaneously, will they collide? No, they won't. Because they are traveling at different angles, and because of that, their pathways will be different. And the time that they're in the air will also be different.
That's a ridiculous question. Like, how could you improve that?
Yeah, I mean, something like that, you just have to say theoretically. In other words, you know, to try to prove it, then you'd have to start taking points along the pathway, and it would just take too long. So something like that, you just have to say conceptually, yeah, they're going at different angles to start with, and they're in the air for different times, so they won't collide.
Oh, nope, the next one.
So that was kind of a stretch for a question. How many joules of energy were lost to heat before the brick stops? So your kinetic energy is equal to your spring energy plus your work energy. It's all for the work.
That's it. God.
3.36. In other words, you know what your kinetic energy is, 1/2 mv squared. You know what the mass is, you know what the velocity is. You know what your spring energy is because you know how far the spring coiled up. You know what the force constant is. Well, the difference between this and this has to be what was lost due to heat, which is friction.
More. That's ridiculous.
Okay, AP questions at times are disconcerting because you would think it should be a little harder. Well, they're not. Or they are, but they're not if you know the answer.
Oh, okay. So what was the work?
The key is, practice it up that you know the answers.
Alex, what was the work again?
3 point something.
Okay, I have a person at home, I have a person in the audience. Okay?
What was the answer?
Well, in the audience, you're traveling at 348 meters per second. Okay, which is given. And the person in the audience is 10 meters away, so it's going to take 0.028 seconds to get there. Now, for the person at the other end of the radio, they're traveling 500 kilometers, but the signal is traveling at the speed of light, 3 times 10 to the 8th meters per second. So in fact, if you are listening to the concert at home, you will hear the singer considerably faster than you will in the audience. So you don't have to fight traffic or anything. You just turn the radio on.
Wait, doesn't radio have to go through stuff first? Like a tower?
Okay, we turn on an air conditioner. So what does that change?
Speed of light.
That changes the temperature of the air in the auditorium. So the time in the auditorium is going to change. Because the air gets colder, the velocity gets slower.
There's no numbers.
Okay? And so now my velocity is 345 meters per second as opposed to, oh, it goes faster. Okay? So 345,
No,
it's 348 before, so it goes slower because it's cooling down. So I'm only going 345. Instead of 0.0287, it's now 0.03 seconds. The time for the guy at home is still the same because it's not, your electromagnetic wave does not depend on air temperature. So the person at home still hears the sound faster.
You just
The
wait.
guy in the audience doesn't
So let's,
mind the
okay,
weight
so we
as
slow
much
down the
because it's cool.
velocity.
Okay, the radio broadcast is carried by another station which is operating at 10 kilocycles faster at a higher frequency. Okay, in other words, instead of listening it at 1090 on your radio dial, you're now listening at it at 1100 on your radio dial. Different station. Okay? Which station reaches the home faster? Well, the frequency doesn't affect the velocity.
So there.
So they both hear it at the same time.